So this is workshop 1 of the scholarly professionalization and radical knowledge series that PD and I have collaboratively set up. And it's run between our feminist laboratory and Crunch Labs. So we're excited to welcome you to this. And we're also excited to welcome the unrivaled Dr. Harvey Quamen from the Digital Scholarship Center. And the DSC is a wonderful resource, and they've done a great job partnering on this event with us. So yeah, big thanks to DSC and Harvey.
I will also very quickly mention that next month, in the last week of February, we're going to be holding a workshop on academic conferences and everything you need to know about applying to them. What are they? How do? And then the month after that, at the end of the March, we're going to be doing an intro workshop on data scraping run by Peter over at the DSC. So polls and info about those will be forthcoming shortly. Okay.
Perfect. Thanks, Nicolette. Yeah, as Nicolette said, my name is Harvey Quamen. I'm a professor here. I have a split appointment between the Digital Humanities program, of which we have many students in here, and I have a split appointment with the English department as well. I used to be a computer programmer, and then I left it for the jet-setting, high-paced lifestyle of an academic, and then I got a PhD in English. I teach mostly in the Digital Humanities program now, where I teach programming, data visualization, databases, algorithms, stuff like that. I wear a couple of different hats. I'm the academic director of the Digital Scholarship Center, which is over on the second floor of Camden Library, where my colleague Janelle, who will introduce herself, also works.
So I get to do fun things like support you guys in integrating technology into it. I teach workshops, a lot of media production things. I'm a 3D printing nerd and a printing nerd. So if you ever want to make stickers, like come on and see. But we're kind of a fun space that no one knows about, but we're not trying to be a secret. So if you have any questions, pop by and yes. But yeah, happy to be here.
Super. And if you're doing this for PD credit, Janelle is the right person to talk to.
Yeah, I'll pass around a board that you can put your information on and designate this for PD credit, yes or no. There'll be also a way for you to put your Gilbert email address so you can make sure that you get live.
Super. Welcome everybody. We're just going to do a little introduction to data visualization today. So if you have your laptop, we can do some work along stuff. And if you don't, you can take some notes and then you can do it later with the recording that PD does. Here's our agenda for the day. We're going to do two little things. The first thing we're going to do is a little spreadsheet tutorial. We're going to do a scatter plot and a spreadsheet. So we're going to talk through that. Like, what's the difference between looking at a spreadsheet and looking at a data viz of that thing? You can use any spreadsheet you want. It doesn't matter. It could be Excel. It could be numbers on the Mac. It could be Google Sheets. It could be OpenOffice. It doesn't really matter. That's the whole point. We're going to talk a little bit about networks today. Networks are a really, really important part of like every single discipline. We'll talk about networks very briefly later. Spreadsheets and other apps don't really visualize networks very well. And so the one that I use all the time is an open source free thing called Gephi. So if you had a chance to download that and play with Gephi, we're going to load some Gephi data. There are some other tools that I will talk about, but we're not going to use today. One is called R, which used to be in the olden days a statistics package, but it has one of my favorite data visualization libraries, which is called ggplot. So I use it a lot for that kind of data visualization. We're also going to talk a little bit about D3, which is data-driven documents. This is how you can make interactive data visualizations on the web. That one is a little bit beyond what it's a little bit beyond what we're going to do today, but I just want to show it to you because if you're looking at data viz stuff, it is a super, super, super place for inspiration. Some of the students have already seen that. It's a super duper place to go and say like, oh my God, I didn't know you could do that sort of thing. It's really pretty cool. And then at the end, we'll talk just a little bit about books, finding the right books for you. Yeah. All right. So what I want to do first, I don't think there's anything else. Nope. I don't want to go there. That's all right. So the thing that I want to do first, if you look in the DataViz folder that you may have downloaded, hopefully, It is on Google Drive as a zip folder or a zip document, which means that it has been compressed and it's smaller. Some operating systems and Google can look inside a zip document to see what's in there, but not everything can. And so what you should do is double click on that and see if you can unzip it and decompress it. You can sit next to me if you want, or there, it doesn't matter. Oh, of course. No, it's all right. Anything I missed today, by the way, Alvik is going to fill in. And so if I get tired, I'm just going to pass it over to you. So, okay, that's fine. And so there are 3 folders in there. Sorry if this is a little hard. It's okay to read. Inside the database, there are a couple of different folders. There's one for data. That's where we're going to work through our stuff today. There's one for slides. The PDF slideshow that I'm showing you today is all in there. So you guys already have that. You can mark that up if you want to. There are some tutorial documents here as a PDF. So I'm going to work through stuff that you guys can see here. But if you also want to look at the documentation, there are PDFs and they're just inside that folder, and then you can follow along. You can do all of those sorts of things, which is pretty cool. Inside the data folder, you will see a couple of things that if your operating system is showing extensions are going to be .csv. CSV is the basic bare bones data format for every spreadsheet in the world. And so one of the things we're going to do is open some of these. So there's several CSV folders in here. There's also an essay by Carlo Ginzburg. We'll talk about that when we get to networks. I am going to open the one called women.csv. And so if you guys just double click on that, it's probably going to open in your spreadsheet. I set up my computer differently, so it doesn't. So I'm going to open it in the spreadsheet. So I'm going to open mine with numbers. Numbers is a Macintosh. Make this bigger. I can't talk and think at the same time. So let's see how to modify this. Numbers is a Macintosh spreadsheet, but you can do this in Excel. It doesn't really matter. Every spreadsheet app can read CSV files. There's women and men. You can open either one, either women or men. I just happen to open women. This is actually part of a data set that I found many, many years ago, and I saved it for myself. I'm not going to give you any secrets, but it is. Come on in. Hey, find a seat, find a chair, find a friend. These are parents in parish churches in East London. And so what you see here is a year and the age of the woman who is registered as the parent, so the mother. The men are the same data set, except it's men, fathers instead of mothers. So what you can see here is that in 1565, there was a woman who had a child christened in one of the parish churches in East London, and she was 25.2 years old. In 1568, there was a woman who had a child christened in a parish church in East London, and she was 22.4 years old. And if you scroll down, you can kind of see most of them are in their 20s, in the 30s, et cetera, et cetera, et cetera. And there's 18. Sometimes I open the men instead of the women, and a lot of the men in here are 15, 16, 17 years old, which means they should have been out playing video games in the 1600s, but they weren't. So what I want to do is, if you scroll down, you can see there are actually quite a lot of rows in this data set. I'm going to put my glasses on so I can see that. 1,657 rows. And you can scroll that data all you want to. Yeah, there's somebody who's 16, 30 something, et cetera, et cetera. So I got a couple of questions for you. Number one, can you see any interesting patterns in this data? Yeah? George?
They are trending slightly over.
Oh, it looks like they're trending slightly older, perhaps. That's good. Yeah. Any other patterns? That was going to be one of my questions. Do these people study get older over time or younger? But that's good. You already got them. Any other patterns that you can detect or see? All right. Can you see any rows that seem like mistakes? Maybe not. Sorry?
Maybe some.
Oh, maybe some duplicates, perhaps? Maybe. Yeah. That seems perhaps unlikely. Yeah. How many of those do you think we have? Hard to say, isn't it? Yeah. Okay. All right. Here's another question. Can you figure out if two or more rows belong to the same person? The same person. Not really, right? That would be very difficult in the group. Yeah, okay, super. Well, those are the sorts of questions we might want to ask about this data, but in this format, very, very, very difficult to answer. And we maybe make some guesses, but it's difficult for you. Yeah. Nope.
Well, parents,
Yeah,
data sets,
yeah.
are those correlated? So that, for example, 1813 from year 1745, the female parent and the male parent will be the parent of the same child,
It's
or are they completely distinct?
it is very likely that they would be correlated. Yeah. So if we open men, we don't have any other kind of metadata. And we open women, we don't have any other kind of metadata. It's very, very, very difficult. I love this question, by the way. I'm going to steal that from you. It's very difficult for us to see if we could pair up a father and a mother from these two data sets, right? That would be very difficult to do. In fact, I'm stealing your question. All right. So here's what I want to do. We're just going to use the spreadsheet app that you have, and we're going to do a data visualization of this, and then we're going to start to look at it. So one of the things that we need to do, if you're in numbers and Excel is the same thing, I need to highlight both of those columns. I can do that with the shift click. And then in this app, Excel might be a little bit different. I want to do a chart. And the chart that I want to do is a 2D scatter plot. And that's down here in the bottom left corner. You can do different color schemes. You can do all kinds of funky, crazy things like that. Super duper. I need a little more screen real estate here. That's what my data set looks like now. Unimpressive, I would say right now, to say the least. This is the thing about different spreadsheets. They're very, very easy to use, but sometimes they're a little bit difficult for me to navigate. So here's what I'm going to do. My chart is already selected. You can see because I've got different dots on all four corners. This is just what I'm doing in numbers. Excel is going to be a little different, but that's all right. I'm going to go under series, and my data symbol is a circle. I'm okay with that, but the size is terrible. I'm just going to put in size equals 2. Now I have some better dots. They're a little smaller, and now I can kind of see what's happening. The chart, though, is kind of too small. So what I'm going to do is I'm just going to make this bigger. I'm going to hold down the shift key, and I'm going to drag the corner, and I'm just going to make this pretty big. A little bigger than I need it to be, but there you go. Now I can kind of see what's happening. So you can see the two parts of this. There is an x-axis along the bottom and a y-axis along the top. The bottom are all of the years. So that is the year that went in that first column, and the y-axis, the one that goes up and down, is the age. So I can see how old the parent is. Every row in that table gets a dot. So now I can see what's happening. So let's go back and revisit our questions. Can you see any interesting patterns here that we didn't notice before?
Like mounts within a year, like number of weeks.
Yes. So we can see that as we go further in time, we get more dots for sure. Absolutely. And now we can see the parts of that data set where we get lots and lots of data and where we don't have very much data at all. We can see both of those. Yeah. Cool. Other patterns that you can notice? Yeah.
So let's see what the actually go up and see kind of this record what you can see.
Yeah, we can see the spread of numbers that we didn't see before. As you suggested, it looked to us by a couple of data points that people are getting older over time. And I think this shows us pretty accurately that, in fact, they are. Parents are getting older over time. This is a trend in the men as well. I'm going to show you how we can see that more clearly in just a couple of minutes here. But yeah, that's one. What else do you notice? Oh, we can totally see the outliers. When I said, are there any mistakes in here? And you pointed out somebody was 56. Look at all these people up here in the upper right-hand corner. Like, what is going on there? Now we have visually a confirmation that some of these are outliers, and we can go back and we can find those rows in the data set. We could go back to the archive and we could try to figure out what's wrong. So just quickly, one thing is it maybe is just a mistake in the transcription. Somebody wrote the wrong date, did something like that. Could be a mistake. We could go back to the original archive in London and we could check that out. There are all kinds of other things that could happen. They may be mixed up two row, whatever, we can find all of that. But there's maybe another explanation too, which is it's very possible that the mother died in childbirth and that this is a grandmother who is stepping in and taking over as the parent of record. So if that was something that we were really interested in, those 5 dots up there in that corner, that's where we want to go investigate further. So it's not necessarily the case that those are going to be mistakes, but those are new things that we can explore in detail, right? All right, cool. The pattern that I saw when I did this, I was sitting at home on a Saturday morning and I made this and I opened it up and I was like, holy shit, what is going on? And it is the diagonal lines. Like everything is diagonally going up and to the right. Why do you think that is?
What page would we?
Close. That's a very good guess. So let's say that I or my partner has a baby in pick a year, 1650. And so there's a dot that goes on there because in 1650, I was 35 years old or whatever. Figure that out. We have another child 2 years later. And so I get another dot. It is 2 units to the right and it's 2 units up. And so what this shows us is that diagonal pattern are the same parents having multiple children. And so the question that we could not answer before, which was, do any of these rows belong to the same person? Now we have some visual confirmation that we can start to pair these up. And it would be the case if we did the men and the women together, that there'd be 2 people, they're not necessarily the same age, but they're going to be 2 dots on exactly that year, right? And if they have multiple children, you're going to see that pattern of 2 dots, 2 dots, 2 dots, 2 dots going up and to the right all the time. Super. Yeah. And so what this means is if my records were wholly and totally accurate, I can in fact find people who are having multiple children because they are on a perfect 45-degree line. And so I could do that visually. It doesn't look like 45 degrees here because my scale of X and Y are not the same. But if those were 1-to-1, these would be total perfect 45-degree angles. And in fact, if you know some mathematics, some trigonometry, you could start to figure that out from the raw data itself. You could calculate angles between dots, but we don't necessarily need to do that. Some people like to do that. But all right, I'm going to do one other thing, and then we're going to go a little farther. One of the assertions that we made, and we can kind of see this visually here, is that people get older over time as parents. And that's true. We can see that visually, but if you know some statistics, we can actually do some things to confirm that, and we get some numbers. That thing is called a trend line. And I just want to do a linear trend line. This is in numbers on my Mac, on Excel. You get that somewhere else. I'm not exactly sure. I don't use spreadsheets very much. I use other tools more. So yeah, but I'm just going to add a linear trend line. And what you can see is that linear trend line goes from lower on the left to higher on the right. And that tells us that parents are getting older. This makes sense because if you go over to sociology, richer societies have children later in life. And so one of the things that you see that's happening here is that East London is getting wealthier over time. If you know London, this is where all the shipping is. It was the birth of the great British Empire. Everything sailed out of these ports into these ports. And so everybody is getting wealthier as the British Empire grows. Makes a lot of sense. And so people are getting older and older as they have children. The increase in dots is also, I think, related to the growth of the British Empire, because when you invent an empire or you colonize somebody, you also invent record keeping and bureaucracy, because you have to keep track of the empire. And so record keeping and bureaucracy is growing over time, and I think that's why we get more dots later. It also became a law later that you had to register all of these sorts of things. There are some places in here where you can see that there are very few dots. And this is one of them. It kind of goes from the 1650s into the 60s and 70s. Anybody know anything that happened in the 1660s, 1670s? The Great Fire of London happened. Yes, which burned basically everything down except a couple of buildings in London that you can look at. So yeah, the Great Fire of London kind of disrupted this a little bit. Yeah. And anything else? The plague. The plague happened as well. And so different kinds of events are going on in the history of London. And so we can see that during some of those events, the record keeping kind of fell down, broke down. Yeah, nothing. Super good. Want to, I'm just going to show the equation. This is a little bit mathy, so you don't really need to know this. We can confirm visually that that line goes up over time. If you like the mathy stuff, the number that we want here is in front of the x, 0.0235. We can look at that number. If that number is positive, it means that line goes up. If that number is negative, it means that line goes down. If that number is 0, it means that it just holds steady. And so depending on what you're working on, you might need that number too, 0.0235. The positive number tells you that these are getting older. All right. So what we just did was we plotted some data, we found some data, we plotted it, and we're looking at it. We were asking a series of questions, and we were answering it now in 3 different ways. So one of them, the one that we're interested in today, is that we were answering some of these questions by drawing a picture. And that's all what data visualization is all about. We were exploring it through words and persuasive rhetoric, if you want to say that. We can answer questions through persuasive rhetoric as well. And the third way is that we can do it through numbers. So that 0.0235 might be very persuasive for certain kinds of audiences. Maybe not everybody, but certain kinds of audiences are going to be very interested in that, right? Yeah. So data visualization is like one of those 3 major ways that we can use to explore questions and to answer questions and to give people answers to questions. all I wanted to say about that. Any other thoughts or comments about the little Excel one here or the spreadsheets? Wonder what's happening? No, you're good. All right.
Is this thing
Oh.
of the food? Yeah. but it's issue.
Oh, so you can't get the linear one in?
But
Oh, is that right?
I
Oh,
think we're
okay. Maybe we have a little time after. If you have some time, we'll just take a look at that and then we'll figure that out. Yeah, okay. Yeah, super. All right. So the positive thing about spreadsheets like this is that, and there are a number of different kinds of data things that we can do, different kinds of charts. You have all kinds of different chart styles here. Well, all that. Chart type, yeah, here's one down here. So there are all kinds of things you can do. You can do pie charts and stacked graphs and bar charts and what we call histograms. You can do all kinds of things. So spreadsheets are pretty easy to get to start to explore some of your data, but B, they don't always give you a lot of control over what you're seeing. And so one of the things that happens as you do more data visualization is that you start to graduate to more complex tools. They're a little harder to learn. There's a little more of a learning curve for those, but the trade-off is that you have way, 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 way more control over what's happening, way more control over the representation, mixing and matching data, removing or adding outline. You can do all kinds of funky things with stronger tools. We'll talk about those in just a little bit. That's super. All right. For a second, I'm going to go back to the little slideshow here, and then talk through this and then set up networks, and we'll work on a little Gaffney one here in just a couple minutes if you want to. So again, there was our agenda for the day. There are a couple of people who I really, really, really quite like for data visualization writings. My joke is that finding some people who write about data visualization is like a date. You just have to find somebody who gets you, and not everybody is going to get you. And so people are going to recommend books, and then you read them, you're like, that didn't do it. And you think that was nothing. So this is one guy who I particularly like, though. I mean, it's happened to have this book in office too. This guy's name is Alberto Cairo. He's written several books. This one is called The Functional Art. This is a lovely data visualization. It's terrible resolution on there. It's a slope graph, but it's a beautiful kind of different kind of data visualization that you can do. But Cairo is very good because he explains his thought process. He was a journalist. He's an infographics designer, worked in Brazil for a number of years, and teaches now in the US. I don't remember where, to be honest, but he teaches data visualization, graphic design in the US. But one of the things I like about his books is that he goes through the thought process that he's using when he's building data visualization. And he doesn't use any fancy tools. He starts with Excel. And so he does some other stuff later with the graphic design stuff, but that's okay. But he makes that argument here, which is the same argument that we just made, which is he starts with a table of numbers. He's looking at population, world population, and he's like, hey, does Spain or somebody, how do they relate to Sweden? What's going on? And he's like, this is too hard. I got to memorize numbers and I got to look at them and I can't figure this out. I need data visualization in order to do that. So he went through that same process that we just went through too. And so he sets up a couple of things. This is the chart, the same one that we just did. I did this in a different data visualization package, and I color-coded the dots for men and women differently, and I made them hollow so that you can kind of see through them, and you can see the density of all of those numbers. You can see that there are the same outliers for women that we just looked at in Excel, but men are like way off the charts. So again, if we were interested in those, we can trace those back to the records in the spreadsheet. We can do some more investigation, et cetera, et cetera. But you can really start to see where the data density lies. You can see where the outliers are. You can see the bottom hangs out to be pretty much the same, but the top is where things change, right? And we just kind of talked our way through that. Yeah, why do the diagonal lines show up? Ages over time. We talked about all these things already. And you can see that there's a kind of even a bit, when we get everybody in there, this kind of weird stair step pattern that starts to happen. And so we can go back to the historical times to see what's really going on at that period, right about 1600 roughly, and about 1700. Why do these things start to happen? Are there changes in the laws, changes in the registration at the parish churches? Maybe there's some historical moments that are going on at that particular time, and now we can trace those back and we can see what's happening there.
For example, if I look on technology sites, again, with fireworks, you'll notice the ages of the males go up. Well, if I remember correctly, it was the shipping area where those fires started. So would it be the higher income, then with the women, those records would be more likely to be kept, and those men would be older?
Could very well be the case.
Would that be a
Absolutely. Yeah.
hypothesis?
Yeah. Indeed.
It's interesting how that skyrockets.
Yeah, it does, isn't it? Yeah, I think so too.
And the rest of the data is missing.
Yeah. And in fact, we could even look at some of the historical records. We could go back in the works cited, I list where this data archive is. We could probably look at the original study and see exactly which parish churches they were looking at. And then we could track them through the Great Fire of London in 1666. There's one in East London I know that did survive. And so it would be interesting to see if they're going to that particular parish church, because they would probably have the most intact set of records. But yeah, I think that would be a really interesting question.
The data is quite different.
Yeah, it is. And so this is one of the things that's interesting about data visualization too, is that we're not using this at the very end to argue for our results. We're using it as a means of exploration. So as we start to look at the data, and we look at the data really early, we're seeing these weird patterns, we're seeing anomalies, we're seeing trends, we're seeing gaps in the data. We're seeing all kinds of interesting things that are leading us to more questions. That's going to maybe take us back to the archive, take us back to some historical research. So we're learning more and more about the thing that's happening because we're seeing these patterns in the data. I'm not just saving it for the end. My joke is going to be, it's like gangsters in Chicago in the 1930s. Vote early, vote often. We're going to do the same thing. We're going to do data visualization early. We're going to do data visualization often. And it's a way for us to explore that later stuff and see what's happening. Super. Word outs in later years, talked about that. All right. The next one we're going to work on is Gephi. And one of the things that spreadsheets do not do very well is to visualize networks. And networks have become phenomenally important in practically every single discipline on campus. The math goes way back, but if you want to blame anybody for this, you can blame the sociologists, actually. Yeah, it's always a sociologist, because back in the 1930s, they were doing a study. There was one in particular about a home for girls at risk back in the 1930s. There were a lot of runaways. There were a lot of things that were going on. And so they tried to figure out why girls were running away from this one particular home. And so one of the people built a social network and found one person at the middle of this social network who was the instigator for all of that. And so they could track that down. That happened in the 1930s. And so sociology and lots of other people have been doing networks ever since. Shows up everywhere. It shows up in the sciences. It shows up in like cancer research and
Psychology.
Psychology happens in psychology all the time. My PhD is in English. Some of the people in my class who just read an article, Franco Moretti is analyzing the play Hamlet by creating a social network of the people in the play Hamlet and coming to some very interesting conclusions about the play just based on the network and what the network looks like. So networks are happening everywhere. And so I wanted to give you an introduction to some network software so that you can display networks too, because spreadsheets don't do it very well. My favorite library, ggplot, doesn't even really do it very well. And this one is interactive, and so you can start to play with the network as you build it. So we're going to build one of those here in just a second. Networks happen in all kinds of other places too. This is a very interesting one in the history of the internet, actually, as it turns out. This guy, Paul Baran, was trying to demonstrate why in the era of the Cold War, this is in the 1960s, that if they built a network to share data among different kinds of computers, it should be the network on the right and not the network on the left. Because during the Cold War, if Russia sent over some bombs, all of us in this room can figure out where the bomb needs to go on that picture on the left. All of us can figure that out, right? Doesn't take a rocket scientist to figure out that one. There is a weird one in the middle, but even the one in the middle, we could strategize against that one if we wanted to. Yeah, the one on the right, not so easy. And so on the right, no matter which nodes, dots you take out, you can find a way through the pattern, and that is actually how the internet works today. Interestingly, history of the internet, the US government, Department of Defense, is building this. They went to the major technological people at the time, which was the telephone company, AT&T, and they said, we have a very wealthy contract to offer you to build the network, but we want to build the network on the right and not the network on the left. And AT&T said, impossible. We reject your contract. And so today, nobody's heard of AT&T as major players in the internet. That's the history of business right there. So the one on the right did get built. Yeah, it was Bell Labs, part of AT&T, right? Yep. So anyway, they turned that one down. There are all kinds of places where networks show up. Those of you who have been to major cities now, including Edmonton, will have a travel map. This is the London Tube map. That is a network that tells you how to get from point A to point B. The one on the bottom here is a skill tree for a game. And I'm not a gamer and I don't remember what game it is. And every time I do this workshop, somebody comes up to me at the end and tells me which game it was. And then I will definitely remember that. And I'm here to tell you I can't remember that. So I don't know which one it is. But it's how you develop your skills so you can get from, this sort of skill level to that sort of skill level, or build some stuff like in civilization or whatever. And so there are different paths you can get there. The one in the middle is called a dendrogram. This shows you, this is actually from literary studies. This one shows you how closely related passages of text are. Dendo means tree, so this is a tree diagram. Computer people and others draw trees upside down, so the root is at the top and the leaves are at the bottom. Don't ask me why. They're very proud of this, however, so don't bug them about it. So what this shows you is that all of the two things that are close together, and they're always in pairs, if they're close together, they're connected by a tie across the top. And then that group gets matched to another group, and then that group gets matched to another group. The lower the tie, the more closely related they are. This is, there's no label on there, but I know what it is. One of my friends made this, and I say to him, he's like, you're still not showing that stupid dendrogram I made. And I'm like, sure am. So some of you probably heard this. Some people have read Frankenstein, Mary Shelley's novel Frankenstein. One of the arguments is that Mary Shelley, when she started to write this novel at 16, published about 18, 19, something like that, is that she wasn't smart. Girls aren't smart enough to write novels. And so therefore, her husband, Percy, who is a poet, must have helped her, right? Ignoring the fact that her two parents are some of the most famous writers of that period, and that she hung out with writers, and that doesn't affect. They just ignore all of that sort of stuff. So what my friend did is he said, I'm going to take some stuff from her husband, Percy Bysshe Shelley, and I'm going to do a stylometric analysis with stuff from Frankenstein, and I am going to see how closely related they are. So this is matching literary styles. Frankenstein is all the stuff in the red. Percy's stuff is all the stuff in the green. They're not related at all. Not even close. So this gives a, that's just not true. Frankenstein's a good one to have arguments about because it doesn't matter. I love teaching Frankenstein and I love debunking all of the arguments about it, but that's okay. That's just me. The other book is Macroanalysis. This is by Matt Jockers. He was also studying literature. This is a pattern of influence in 3,500 Victorian novels. So this is a giant network graph. All the dots are novels, and the lines that are connecting them is a positive correlation of literary influence. So what you can see is who's reading whom and how influenced are they by those different novels. And then you can start to see people on different outliers and things like that. They're color coded. I don't remember what the color coding is, but you can look at that. And he used Gephi to produce that. So Gephi scales very well in those regards. The circle one there is one that I did. We were digitizing some of the authors who were here in the English department. And I was trying to figure out their social network. They were very, very, very tied into Canadian literature, playwrights, poets, publishers. I was trying to figure out their social network. This is only 1 year in their archive. The two authors are in orange. I don't know, I'm looking over there from here. The two authors are in orange. And then the radius or those concentric circles are how closely tied they are to the person in the middle. So other dots that are closer to the middle are more closely related to that person, and then you kind of work your way out through spheres of influence. It's a different kind of way to visualize a network, but all of these things are different kinds of networks. So there are many different kinds of visualizations that you can do with these networks, but we're just going to use Gephi today to build a class of them. I might come back to this part. Nope, I'm not gonna. Nope, I take it back. I'm not gonna come back to that. One of the things that we do need to do for Gephi though is that like I did with the spreadsheet app is that we need to clean the data. We need to put the data together into certain patterns. Gephi needs two spreadsheets. And so as we're going to use Gephi, we have to take the data that we're interested to use and we have to build these two spreadsheets. We can do that outside of Gephi. And in fact, I did build a lot of this stuff watching television. I'm binge watching stuff on Netflix. I know it doesn't matter. You can do it any way you want to, but it needs two of those things. So one of the things that people love to talk about in data visualization is that you can't just take this unstructured data and dump it into something. I can't just take all of this text and dump it into Excel and then expect to get a data visualization. I can't take data like all of the characters in Hamlet and just dump the whole text of Hamlet into Gephi and then get a data visualization. So I've got to do the data prep work to do that. Even people who work at Google are like, yep, you're looking up stuff on Google, but Google spends 80% of its time cleaning data. 80% of its time cleaning data. Sorry, but you will too. You'll spend a lot of your time cleaning data, and so you got to figure out how to do that. This is just a nice image that moves from, disorganized, kind of unstructured data, and then structuring it in a particular way, and then gaining information out of that. I will confess to you, I've already told this to my students, this idea about data versus information versus knowledge versus, I don't think that matters at all. I have no interest in that. Doesn't matter. Okay, it doesn't matter. That's different. All right. So here's what I did. There's an essay that I like to teach. Excuse me. It's from the 1970s. It's by Carlo Ginzburg. You have it in your data package. It is called Clues, Roots of an Evidential Paradigm. He does this really nice kind of intellectual history that does not follow art versus science. And instead, he's looking at places where information gets repeated and has a definite pattern, and that leads to things like physics. And so then you can start to write equations and stuff like that. So it's repeated data. What he's interested in are the other kinds of disciplines historically that don't do that, and they look for individual bits of data because they're significant. And those are clues. So for example, all the way back, people are like, it's pretty gross, but you are opening up a bird and the bird guts spill out, and then you're reading the future in the bird guts because you're looking at the details that are happening in there. There are all kinds of these, as he says. Law is one of them, because you're looking at all of the different kinds of precedents that are happening, and all of those details matter in law. It's not like you're having an equation about the law or anything like that. You have to look at the details. Literary studies does exactly this too. We look at the details in Shakespeare. We look at the details in Jane Austen. We look at the details because those are the things that really matter. You look at Jane Austen because Jane Austen isn't really like everybody else. Matt Jockers disagrees with that, by the way, because he puts you on that chart, but it doesn't matter. It doesn't matter either way. Detective fiction starts precisely because the growth in clues and details matters. Sherlock Holmes is the great character of figuring out all of the details and putting them together in a pattern. Medicine is one of these as well, because medicine has to look at all the symptoms of somebody, and they have to look at all of those tiny, tiny, tiny little details and then put those together into a diagnosis. So if you know the history of medicine has been vexed and has not been accepted or incorporated as a science for a very, very, very long time, which is a very interesting part about the history of medicine, right? All right. He's all over the map. And as I was reading this, I was like, my God, Carlo Ginzburg, he's an Italian scholar. Like, it kind of seems to me like the entire history of this is Italian. Why is that the case? And so I started to get very curious about why all of these Italians, I know there's a lot of these people I didn't even know. And I thought, what I could do is I could do a graph data visualization of this, and then we could sort of color code things. Where do these people come from? What's their profession? Et cetera, et cetera, et cetera. So as I was binge watching Netflix or something, and I put this together. So what I did is I reread the essay, and I wrote down for every paragraph all of the people he mentions in that paragraph. And so if they're mentioned in the same paragraph, I'm going to put a line between them or a tie between them. And so I'm going to start to see who gets mentioned at the same time, who are the outliers, who are the people who get mentioned constantly all the time. And so I know that Gephi needs two spreadsheets. The first spreadsheet are for all the dots. Every person in that essay is going to have a dot in the graph network. But that data is not in Carlo Ginzburg's essay. So I built my own spreadsheets. I wrote down all the names, and I sat and I went to Wikipedia and I looked up who all of these people were so that I could get their nationality, their status. Are they real? Are they hypothetical? Are they fictional? Their nationality is in there. I put in some dates, but the dates are all wonky, so I can't really visualize the dates, but building a timeline would be super cool, I think, in this project. Their profession, whatever I can think of, that might be like they're known as a criminologist, they're known as a fiction writer, they're known as a scientist in some way, or those of us who watch The Simpsons are scienticians, but we can use all of those sorts of terms. And I put some notes in there because I can't remember anything, so I put some notes in there. You have this, so if you want to open it, it is called nodes.csv, and if you double click on that, you will see exactly this spreadsheet. I'm not going to, but you guys can. It looks surprisingly like that. One of the things that's interesting is that Gephi needs everybody to have an identifying number. They don't have an identifying number in Carlo Ginzburg's essay, so I had to make that up myself. It's easy to do in a spreadsheet. You can add some numbers and drag it down the column. And so everybody gets a number, 1, 2, 3, whatever, whatever, whatever. That's just purely for me. That's nowhere external to me. It's just unique to my own spreadsheet. The second spreadsheet that Gephi needs are how to connect those dots together. Who gets connected together to whom? And so one of the things you'll see here is two columns. There's a source and a target. The source is where the line starts, and the target is where the line goes to. So what that tells me is top row, person number 40, whoever that is connected to person number 50. And second row, excuse me, person number 33 is connected to person number 40. What I did was I counted the number of times these people were mentioned in the same paragraph. So person number 40 and person number 50 are mentioned together, but only in one paragraph in that essay. And that's the weight of the line. So the weight, they're only mentioned one time. Person number 33 is connected to person number 40, and they are mentioned together in the same paragraph 3 times. So they're going to have a slightly wider line connecting them because they've got 3 connections. And if you scroll down, there's one that's 2, et cetera, et cetera, et cetera. Undirected just means there's no arrow between them. We can talk about that a little bit more later if you want to. What's also interesting here is that each of these lines also gets an identifying number. Yeah, you can use that, but you'll notice people, the nodes need to have ID numbers. We use the ID numbers as we're defining how they're connected to each other with a line, but each line also gets an identifying number. Gephi can do some things with it if we play with it, but yeah. I should have probably opened that in the spreadsheet so you can see that. All right. So let's do this. If you have installed Gephi, just going to get rid of that. If you did happen to install Gephi, double click on Gephi and it'll open up. We'll just look at what Gephi looks like. There's some panels here, as you can see. So I'm just going to give you the tour of the panels, and then we're going to load the node spreadsheet. We're going to load the edges spreadsheet. We'll do some color coding so we can see nationalities, and then we're going to do all of that. So the funky stuff. Yeah. By the way, while you're getting there, I will just say the essay, one of the major themes in the essay, one of the major stories in the essay is by a guy whose name is Morelli, and he was an art historian. And one of the things that Morelli discovered was that he was looking for 2 things. Number 1, forged paintings that were forgeries. And number 2, he was looking for art by famous artists that were misattributed. So this thing is really Michelangelo's, but it's really the subject thing. Or we think this is Michelangelo, but it was actually a student, something, whatever, all of that sort of stuff. And the reason that this guy Morelli was very interesting is because he said, I'm not looking for the major themes. I'm not like, hey, this is the Saint Jerome something something, or this is the Virgin Mary, or whatever. The halos are. He looked at all of the weird things. He looked at earlobes. He looked at fingers. He looked at fingernails. He looked at the way toes were painted. And he started to look at all of these really, really insignificant details so that he could figure out, because it's like, hey, if Tishon paints fingernails in this way, they're always going to be the same way. But if you're an art forger, you're probably not going to look at that level of detail, right? And so you're going to get it wrong. So everything was based on the details in the paintings, things that other people had ignored. And he's a major player in this intellectual history. Also Italian, but a major player. And then something really amazing happened. An Austrian, I don't know what he was, we'll call him a scientist, read these pieces. Oh, and Morelli published under pseudonyms too, by the way. So he's got 2 different pseudonyms. That's interesting. That's a long story. So I don't want to get into the whole thing. But an Austrian scientist started to read Morelli under some of these pseudonyms and was like, oh my God, that's amazing. I'm going to use that in this new growing science of psychology that I'm starting to invent. And that person was Sigmund Freud. And so details in dreams, details in your life become significant in psychoanalysis because of these same reasons, right? And in fact, you don't need to know this, one of Freud's essays he published under a pseudonym, and he was like, "What? I just read this essay about this new thing called psychoanalysis. It's really persuasive. I am so impressed by this. I think I'm, it's anyway. All right. So these are stories that he's telling in this essay. Okay. So anyway, everybody's got Gephi up now. So there are a number of panels here. The big one in the middle is where everything is going to happen. This is where we're going to display our stuff. It's where when we open some stuff, the nodes are going to go there, the edges are going to go there. We're going to play around with it. We're going to do all sorts of cool things. There are two panels on the left-hand side. The top one there is called appearance. The bottom one down here is called layout. We're going to play with those in a couple minutes. When we do our color coding, we're going to go into the appearance panel in the upper left. There are some panels on the right-hand side over here, filters and some statistics and things like that. We can start to calculate some of the numbers that are going on in the network as well. So we can see who is the most in the middle person, et cetera, et cetera, et cetera. We can calculate a lot of those things over here. Right now it's on statistics and filters, or stats, whatever. Yeah. There are three buttons across the top. You'll see there's overview, data lab, and preview. So we're right now in overview, or we should be in overview. Data laboratory is going to be the spreadsheets themselves. And so we can edit data in the data laboratory if we want to. Doesn't mean we need to, but we can. If we calculate something like some statistics, the statistics will be added as new columns on the spreadsheet. So we can kind of see where they are. That's pretty cool. For those of you who are going to print something, you're going to do this for a conference, you're going to do it for, class, you're going to do it for a publication, whatever. Preview is the place we need to go. Preview is where the graph is going to get pretty. And then we can save that off as some sort of format that we can use later. So preview is where that's going to happen. But all of our work is going to happen in the overview over here. So what I want to do under Gephi is I want to go under Gephi here under File. I want to import a spreadsheet. I have already navigated to where my data happens to be, but you can use this panel to navigate to wherever your DataViz folder was. And then inside DataViz, you can go into the data folder and you can see the stuff. This is where decompressing that zip is going to be important because Gephi has a hard time and I think really can't actually look inside zipped data. So you've got to unzip it so that Gephi can do it. Google can see inside zip data. Operating systems can see inside there a lot of times. Probably a lot of other apps can see inside zipped data. Gephi can't really. That's it. So the first thing I want to do in there is I want to load nodes.csv. So I find nodes.csv and I go down here and I click open. And then we're going to get a little wizard. And the wizard is going to say, here's what I'm trying to bring in. Does everything look okay? I know you can cancel at any moment if things are going to go sideways for you, right? But as I'm looking at this, it looks super cool. It looks good. It says here it's going to import it as a nodes table. That is lovely. That's beautiful. Character set, UTF-8. This is sometimes called Unicode. I will stay off of that soapbox today. Everything you ever work on, forever and ever, world without end, amen, should be UTF-8. Enough said. Okay, I'm going to click on next. This just says I'm going to bring this sort of stuff in. These are strings, alphanumeric sequences, et cetera, et cetera, et cetera. Yeah. That's all great. That's super cool. I'm going to click finish. And now I get this last one. And this is one where we have to pay particular attention because there's something very important that we always have to make sure of. So it says no issue found during import. You can see there are 92 nodes here. So there are 92 different people mentioned in that essay. Number of edges right now is 0. We don't have any of those. But what I want to do is I want to append this to the existing workspace. That's that big panel right in the middle. That's our workspace. So I don't want it to build another one of those middle panels and then stick it over there. I want it to stick it in this one. So I want to click append to existing workspace. And there are my notes. So right now, they don't have anything on there. I can't really see who's what. Gephi places these randomly. So there is no rhyme or reason for where they go. They just go kind of randomly. That's why you can see some of them kind of overlap each other, whatever. It doesn't even really matter. That's fine. So there's nothing there. So the next thing that I need to do is to import the edges. So I'm going to go back to File, File, Import Spreadsheets. And I'm going to get the second one, and this one is edges.csv. Nodes and edges.csv. Same process, we're going to get a little wizard. So I'm going to click open. I'm going to get the little wizard. You can start to see the columns that are showing up there. The data, like source 40, target 50, weight 1, 33 to 40, weight 3, etc., etc. We already looked at that a little bit. That looks super cool. Character set UTF-8. I promised I wouldn't say that again. All right. And then this is all great. This is super cool. Don't worry about any of this. I'm going to finish. And you can guess what's going to be important about the last screen. Append to existing workspace. If I didn't do that, it would build a new central panel. All the nodes would be over in this one. All the edges are going to be over in that one. And I can't see anything. It doesn't really matter. There are no nodes in the, it would be just a mess, an absolute mess. So I want to add those to the existing workspace. And I'm going to click OK. And now I have it. You can see that some of the people get mentioned with other people a lot. So some of those lines between there are very, 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 very heavy, which means they're mentioned together in the same paragraph more than once, many times, as it turns out. And you can see, especially down here now at the bottom, there are actually a couple of these dots. Pretty cool, I'll do that short in the middle. There are a couple of dots that are not connected to anybody. And what that means is that they are alone by themselves in a paragraph in that essay and say they're not really connected to anybody, right? Yeah, super. If I mouse over one of these, you can see that all of the other edges sort of fade to gray, and I can see the connections between that node, that person, and the other ones. So I don't really know right now who this is. We'll figure this out in just a second. But they're connected to a bunch of people up there and up there and up there. So they get mentioned in the same paragraph with all of those other people as somewhere along the line in that essay. Right? That's cool. All right. Oh, I'm sorry. Yeah, Christina.
So every time you put it out, it's going to be dispersed randomly every time. So it might look messy sometimes. So if you don't like how it's scattered, you can just reload it, kind of figure out it better.
Yeah, you can, yes. And then so, yeah, you can reload it if you want a better distribution. I can actually, even right now, I can drag these around and I can move them. That's generally not something that I'm really going to want to do very much because the layout are algorithms that draw this much prettier. So the solution that I want to use is to choose a layout algorithm and then.
When you imported the file, it's the number of nodes was 92.
Yeah.
And then when you imported your edges file, it's the number of nodes is 3. Is that just taking into account like the little isolated guys that are not connected to anything else, or what's the
For observation, that is exactly what happened. So when I imported the nodes, there were 92 nodes, so there are 92 people in that essay, but only 83 of them are connected. And so that means that there are 9 nodes that are not connected to anybody else. They don't have an edge on them. That's super good observation. Nope. I had a super goal. For all the times I've taught Gephi, you're the first one to notice that coming in. So it's super duper. You get a gold star today, basically.
Get an awesome.
Yes, thank you.
And a gold star. So yeah, that's cool. All right. So what I want to do now, the question that I started with, when I was going to look at this essay was like, I think all these people are Italians. And that's why in my spreadsheet, when I was watching Netflix, I wrote down what they are. Oh, by the way, if you just want to see that, you can go to the data laboratory, click on data laboratory on the top, and then you can sort of see the whole spreadsheet here, right? And so you can see the columns, it's label, interval, status. Nationality is the one that we've got. The dates are a schmozzle, so that's not really going to help us right now. I would need to clean up the dates so that I could use them properly. I didn't do that. But profession is another one that might be really interesting for us to look at. Yep. All right. And so you can see those are the nodes down here in the upper left, down in the upper left corner. My English degree coming out down in the upper left. I just clicked on nodes, and if I click on edges, here's the edges table. Right, I can see the edge table. There's the nodes table. So as we calculate some statistics, we will get more columns here on the nodes table. But I'm going to go back to overview for just a second. And I want to look again in that upper left-hand corner. I want to make sure that I'm on the appearance tab. And I'm going to click nodes, which is already clicked. And then under nodes, I want to click partition. And here I get a pop-up menu. And if I choose an attribute, you'll see that these are the columns in the nodes table. So these are now attributes for those dots. I'm going to click nationality, and you'll see that I get some color coding there, but I need to click apply in order to apply that data to the graph. And when I do that, now you can see all of the nodes that get color coded. Italian is this kind of nice pink color, I guess. Mauve, maybe? I don't know. I don't know my colors very well. Like, oh yeah, there is a lot of Italians. Italians are all over the place. And in fact, you will notice, because, these are and you can see the stats there, right? The percentages of how many is each thing. French, German, Greek, English is way down there because he's Italian and the British never did any. So yeah, very interesting. The only ones worse are the Austrians and the Americans. Okay, so we can see all of those sorts of things. I can still drag these around, but I can mouse over these. I can do all of that, but I'd still like to see who these people are. So for a moment, I'm going to make this way worse, and then we're going to make it better. Down at the bottom is where I can add labels to the node. So down at the bottom, there's a T, a black T down there. I'm going to click on the black T. Run! Thanks, everybody. That's the whole workshop. We'll see you next time. Thanks for coming. Bye. You can change this in the preferences, by the way, so that it doesn't come out as terrible, but I like the moment of shock when we do this. You can see, you can probably guess what we're going to do next. This is Arial bold 32-point font. And so there's a little slider here. And so what I'm going to do is make this much smaller. And so now we can start to see people and what's going on, what's happening. I can still drag these around. A couple of things. One of the dumb things about Gephi, I'll show you a way that they've started to try to fix this. Number one is zooming in and out, a little bit challenging. You can do it, especially if you have a mouse. It's built especially to use mice, but you can do it with the trackpad too. on the Macintosh, I'm going to show you a different one. Click and hold and a two-finger scroll. It's just like a complicated kind of thing. It's like, some sort of, piano configuration. You're playing cool, and it doesn't matter. But the other one, you can scroll around, you can move the graph with a right click and drag. Or if you're on the Macintosh, hold down the control key and then drag this around. So you can move it around like that. The best way to zoom is down here on that bottom panel, way on the right, there's a little triangle. And if you click on that triangle, you will see here in the middle, there is a zoom slide. So you kind of have to open the drawer, as it were, to get the zoom slide. So I can zoom in a little bit. Yeah, you're already in the front, I can tell. And so this is a bit of a schmozzle. It's not very easily readable. However, I'm going to hold down Control and scroll a little bit. And you can see the major connection here. Surprise, surprise. Sigmund Freud is connected to Giovanni Morelli, who is the art historian. And so even if you haven't read the essays, and even if I didn't narrate for you the spoilers, you can see on the data visualization that the centerpiece of this essay is the connection between the art historian and Sigmund Freud. It is that intellectual connection, that intellectual correspondence that he's very, very, very interested in. That becomes a major piece. Obviously, there's a lot of players here. There's a big cast of characters, but that's not the only thread in his essay, but it's a major one. Yeah. All right. Just looking for his Morelli's. Oh, here's right. Sorry.
We have a couple questions.
Oh, I'm sorry. Sorry, question. Sorry. That's a great question. What I might try to do is go to the filters tab and then filter the negative. That's what I would do. Yes.
This is kind of like control app. It's like where you get to.
Yeah.
Particular phrase.
Yeah, you're right. Yeah, we can do that. So let me look over nodes. I want Queen Victoria. So yeah, Control F, Command F, Control F. There you go. That's super. Thank you. I usually don't do that because I'm interested in the whole network of the one time. I can also look at edges apparently with that. So that's cool. Super. All right. So yeah, please. Oh.
I just wanted to, so the thickest line, right, which is between Freud and Morelli, just because I haven't created the data set. How was the difference between the 50 and 9? Is that determined by occurrence? Is
Yes.
that column?
It is.
I'm just curious.
Yeah. No, you're quite right. And so if we take a quick look in the data laboratory and we click on edges, the column over here called weight has decimals in it. I just counted 1, 2, 3, 4, 5, but it has decimals in it. And what I can do is sort that. I should be able to sort that. So the major connection is between 33 and 84.
And you went through that yourself.
Yes.
Kind of,
I did.
we're trying to point out
Yeah.
how it looked.
So when I built the edges table, I counted them myself. And then So
Between them, themselves.
yes, between that during that, but yeah, it doesn't matter. It doesn't matter. Your workflow may be different. It's okay. So my guess is we can look, but 33 and 84 are going to be Morale and Floyd. I'm pretty safe, right? And they were mentioned together 8 times. And then you can see the 3s and the 2s, etc. So if I go back to nodes and I scroll down a little bit, 33 is right here, Giovanni Morelli in the nodes table. 84 is, lo and behold, Stephen Floyd. So yeah, so they were mentioned together 8 times, and so that's why that line is bigger. I'm going to zoom out again on some trivia, just a little tiny bit. Oh, yep, I can see it. So the Morelli character has 2 different pseudonyms. He gets mentioned a couple of times. You can see them on here. One is I lost him already. Johannes Schwartz, which is over on the left-hand side there. And the other one is, I lost him again already. Ivan Lermolia. Yeah, Ivan Lermolia over there. So he has a kind of a German pseudonym and a Russian pseudonym, and they're writing about each other. And Schwartz is like, I just read this guy Lermolia, super cool. Yeah. So anyway, all of this thing is going on. Yeah. So they're all connected. Yeah. Cool. All right. So the next thing we're going to do, by the way, there's a little button over here on that kind of left-hand panel that centers. It's supposed to center the graph again, so it will scale it and center it for you so you can see it. But again, this is a bit of a schmozzle, and so this isn't exactly what we would want to do if we're going to present this data. And so what we're going to do is go down here on the bottom left to the layout panel, and there is a pop-up list or a drop-down list, whatever you'd like to call it, about all of the different kinds of layouts that we can use. These are algorithms that draw the thing prettier. So they move the nodes around and then they can reconnect them so they get drawn in different ways that are pretty and fun. There are many, many different kinds of algorithms, and so you can play with the algorithms till you get a layout that you particularly like, and then you save it. And then you can save it off as, you know, PDF or JPEG or whatever you want. You can save it as anything. So one of the most common ones that we use is one of these, either UFON-WHO or UFON-WHO proportional. So I'm just going to do proportional. And you will notice when I select that nothing has happened yet. And there is a run button there. And so I need to run that algorithm, and then it's going to redraw the map. And so you can see what happens is, well, I'll explain this in just a second, but you can see there is a lot of outliers here now, and those are not connected to anybody. And they tend to cluster together into groups. So the people who get mentioned together the most start to appear in a visual group. And now you can start to see the visual groups that are happening that display that way. One of the things that happens, and I know everybody will appreciate this because everyone took physics. So the metaphor that this one uses is that every node is an electron. Electrons repel each other. So nodes that are not connected want to push each other apart. But the edges, the lines, are springs. The wider the line, the heavier the spring. And so the big lines pull the electrons back together and the little electrons float away, which is why the people who are disconnected have sort of floated away. In some of these kinds of visualizations, they will fly away into the ether and you will never see them again. I don't even know where they go. Yeah. But what happens is that you can see all of the groups now, and then you can start to, I'm scrolling the wrong way. That's really good. That's really good. I never noticed.
Love that.
Oh, that's great. Super. Oh, that's good. And now you can start to see people who, and we call these ties. And you can start to see people who connect neighborhoods together. And in sociology, they're called ties, they're strong, they're weak, there's a lot of things that you can say about them. But now you can start to analyze that. So here, for example, the gray one right in the middle is Arthur Conan Doyle, who is the author of Sherlock Holmes. And you can see that Sherlock Holmes is down here in one of the orange ones down here. And so Arthur Conan Doyle ties together this group that's at the top, where there is some fiction and some crime stuff, along with Sherlock Holmes, which is down at the bottom. And so Arthur Conan Doyle is a tie, a very important person in the social network, because Arthur Conan Doyle connects together different neighborhoods, different clusters, different cliques of people. If you like that kind of analysis, sociology is going to be your new best friend. If you're not any sociologists in here now. That's why we can say can make fun of them, but that's okay. And so social network theory, social network analysis is all over this sort of stuff, because this is what they build a lot in sociology. There's tons of terms, there's numbers, you can quantify all of this sort of stuff. There's tons of stuff you can do with it. But those sorts of ties are important. And so you can see down here, there's a green one in the middle there, kind of Alphonse Bertillon. He's a French criminologist. Arthur Conan Doyle read Alphonse Bertillon, and then he influenced Darwin's cousin, Francis Galton. He tried to implement some of the same things, but there's a whole bunch of British science stuff going on up here. Julian Herschel, who is an astronomer and a scientist, and then Queen Victoria, who is apparently some sort of monk. So anyway, you can start to see all of the different neighborhoods, and you can see, where people start to fit, because the major connections, those major ties are like springs that are pulling the nodes back together again. There's more sort of gravity there, if you want to say that. And so all of those nodes are going to get pulled into those particular places. So because that connection between Freud and morality is the kind of heart and soul of that essay, this is the cluster of people who really come up in that conversation, in that thread, in that essay. Super. We can do all kinds of other layouts. The one thing that I wish Gephi had is undo. I would like to undo this layout and go back to the random mess that we had before, but we can't. It's lost. But what we can do is just continually apply different layouts, and then we can see different kinds of stuff. So let's do Fruchterman Rheingold. Then I'm going to zoom out so we can see that one a little better. Notice when we click run, that now there's a button called stop. That means that this algorithm continues to try to readjust the locations of everything until we say quit it. Don't do that anymore. So this is very common in some of them that are based on physics, because we didn't see it in the last one, but the electrons and the springs are like a system of physics, and they're trying to come to equilibrium where they settle down and don't do anything. However, a lot of these algorithms don't really reach equilibrium ever, and so we just stop it. So notice that when you're playing with different sorts of layouts, occasionally the run button will turn into a stop button, so you just stop it. You can see that this one is maybe easier to see. It still ties together people who have very strong connections, but because it lays out the graph in much more readable format, it might be easier for you to see. So you can play with these if you're looking for those clusters of people. Maybe the last one we did is very interesting. If you want to see something or zoom in on part of it like this, like, hey, where's Proust? What's happening with Proust in here? What's going on? This one might be easier for you to see. But again, it's because in the overview, generally, when Gephi sets this up, everything is in random place. And that is not to our advantage. But Gephi doesn't know any better, right? Like it can't make any educated guesses about what's going to happen. So it just does the best that it can. O'Reilly's in here. Well, surprise, surprise. All right. Now we can still do other kinds of things too. I'll let you play with some of the other layouts if you want to, and maybe we'll have time in a minute to do that. But let's go back up to the top. We looked in appearance, and then we were looking at the nodes. We can do some stuff with the edges too. Actually, not in this one. I didn't give us enough information on the edges to do anything. We'll look at nodes, partition, and let's just do this again now by profession. Slightly different. Scientist, fictional, artist, author, et cetera, et cetera, et cetera. And so now we get slightly different colors, and so we can see kind of their intellectual lineage or whatever, like their whatever profession, mostly whatever Wikipedia called them, I think is what that is. And so you can see, for example, all of the blue people are artists, and the purple people are kind of scientists now in some way, shape, or form. And this actually shows fictional people. Jean Valjean from Les Mis is down here in the corner. So one of the things that I really like about this essay is that it's not really science versus art. Like all of these people are kind of in the same intellectual tradition. He doesn't really make a distinction between them. And so he's perfectly happy talking about artists in the same place as he is talking about scientists. Like there's no real distinction between those two worlds for him. And so you can start to see this in the data visualization as well. You can really start to see that he's all over the map, but those sorts of distinctions are not things that he's making. He's not making art versus science distinction. He's not making a quantitative versus qualitative distinction. Those are just not things that he's very interested in. And you can kind of see the effects of that, in the network. You can play with some of the other layouts. You might even be able to download some more layouts if you want to. But the one thing that I wanted to show you next, up on the top, we've got overview, data lab, and preview. Well, actually, oh, I'm sorry. Let's before we do that, let's calculate one other thing. We'll just do it on here before we go over. On the upper right-hand side, go over to statistics. And we can calculate a whole bunch of things. Two of the things that get calculated quite often are the number of connections that any dot has. We just count the number of lines. You can count that as just the number of connections. You can count that as weighted connections. So remember the weights between those two was 8, so we count as 8. You can count them either way. Sociology is going to give us some hints about all of that. The other one is a centrality score, and there are a lot of different ways to calculate centrality. Centrality is asking the question, who's in the middle? Of this giant schmozzle, who's the person in the middle? And that's what centrality kind of calculates. And so degree is that number of connections. So if we click on run next to average degree, yeah, that's fine. We'll calculate that. we get a little scatter plot visualization, which may or may not be interesting to you. If you read some social network analysis, I bet you're going to see this a lot. If you read Franco Moretti's essay on Hamlet, he gives you a scatter plot exactly like this. So there are ways that we can do that. I don't particularly care about that, so I'm going to close that window. But I'm going to go back to the data laboratory. And now you'll notice that there's a new column on the right-hand side called degree. That's the number of connections that every node has. If I click on degree, it sorts it. This is in increasing order. I'm going to sort in decreasing order, and then I got to scroll up to the top. So Giovanni Morelli, the art historian, has 33 connections. That means he's mentioned in the same paragraph as somebody else 33 times. But now you can start to see who gets the most, right? The most connections, the most co-mentions in this piece are in descending order. Giovanni Morelli, Arthur Conan Doyle, Mancini, who was an Italian physician, Sigmund Freud, Galileo Galilei, Zadig, who is a protagonist of a fictional novel. And so you can see the people who have the most connections. Those are the people who get co-mentioned the most in different kinds of paragraphs. Right. I'm going to go back to the overview for just a moment. And I'm going to click on another one. We can calculate centrality in a number of different places. It doesn't matter. I'm going to do this one down here. Clustering coefficient does it. It doesn't matter. Let's click on eigenvector centrality. Run that. Do it 100 times. Yeah, that's fine. And then I'm going to get this kind of distribution. If you like the scatter plots, that's super cool. And I'm going to go back to data laboratory again. Eigenvalue, centrality. It's on the node overview, but 2/3 of the way down. If I click on data laboratory again, now you'll see there's a eigenvalue centrality. And this is a number between 0 and 1. It tells you how close to the middle of that graph you really happen to be. And so if I do these in descending order again, this is what social network analysis will say. These are the most important people because they're most in the middle of that whole graph. Surprise, surprise, it's Giovanni Morelli. We would have probably guessed that. This order is slightly different. This is now Arthur Conan Doyle, Zadig, the protagonist of a novel. Edgar Allan Poe is in this one, and some other people. So there are different kinds of measures. One is how big the connections are, how many connections you have to somebody else. And the other one is how close are you to the middle. And so there are about 3 or 4 different ways to measure centrality, and social network analysis can get you there. But anyway, we do that. All right, last one. So we did, this one was the Fruchterman Rheingold layout, and that was fine. But now what I want to do is, oh, sorry, go ahead, please.
So what's the interpretation?
Yes, degree is how many lines are connected to you. In other words, the number of people you're connected to in the network. And so, you know, I've got lots of friends, but centrality is they never invite me anywhere. And so I am not in the middle of that group. And so I'm always at home on Fridays while they're out. But I have tons and tons of friends. So centrality is, and there are different ways to measure it. One of them is, for example, you start on one side of the network and you go to the other and you measure all of those, like who gets crossed the most, you know, stuff like that. And so centrality is, you know, all roads lead to one.
It's like it's picking up basically, even if it's not a directive, it's spatial.
Yeah. 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 You can think about it as Google Maps. Like it's very, very, very difficult to cross this network on on the roads of this network without going through the town called Giovanni Morelli. You know, it's possible to get from one side of the map to the other without going through Giovanni Morelli, but it's very, very likely that most of the roads you're going to take are going to go through Giovanni. All right. So here's our overview. Then the last thing, and then we can look at a little bit more at a couple of slides, and we'll be done for the day, I promise. I'm going to go to preview. And as soon as you click on preview, it's amazing. There's nothing there. And so one of the things that we're trying to do is to do some sort of a nice printable layout that is going to be useful for us. I'm just going to use this on default for just a moment because it's going to borrow some of the tricks and tendencies that we just did. And the clue with the preview is that you always have to click the refresh button down at the bottom. And so if I click refresh, I get a very, very lovely version of that map with curved lines and different things like that. I can do tons of things here. So for example, down at the bottom, I can change the background color. So if I want something maybe, I don't know, a little more bluey or something, I don't know, I can change that. And so you can play with this to your heart's content. I can add the labels back again. So on the left-hand side over here, you'll see it says show labels. I'm going to use an Arial 12-point font. And so I'm going to do that. Now, remember, if it doesn't show up right away in preview, you have to click the refresh button down at the bottom. And so if I click refresh, now I get all of my labels again. And so I can start to see it. So this is where a lot of people spend a lot of time, especially if you're good at design stuff. I'm not. But if you're good at it, you can spend a lot of time here. And so if you go to conferences or you're looking at publications, you'll start to see some really, really funky, cool network diagrams that are going on. It's because they spent a significant amount of time here playing around with stuff. But yeah, and then you can save this. You can just export these, you know, import, generate, or save, right? You can save this, save as in a variety of ways. So whatever you happen to need, you can export as all of that. I will just say this. If you save this file, you'll notice what it's going to save as. Hawk 16, I don't know why it's going to name it that. Maybe that's the last one. I think that's the last one I saved it as. It will save it as like a .gephi. Oh, I know that's a network .c. As a .gephi file. And what that means is that the next time you open this, you don't have to load the CSV files anymore. Everything is loaded. The data is all there. Like we calculated the degrees, we calculated the centralities. All of those things got added to that spreadsheet. It saves all of that. So when you're working on this, you don't always have to start over. If you save it right now, that's you can save it as .gephi. There's some other formats too. If you're curious, just Google those. You can save it. Yeah, there's all kind of cool stuff. Yeah, that was a different thing that I knew. That's good. All right, super. Any questions about that? I know we spent a lot of time on Gephi, but it's one of the places where, because there are networks everywhere, it's one of the places where you get to really show off. You know, it's like, hey, I built these networks. I did this really cool design thing. And these show up everywhere. In my class, students are going to be happy that I didn't give you this one this year. One of the assignments that I gave was to go to Google Ngram Viewer. I made them go to the Google Ngram Viewer and do 5 grams. So it's links of words in pairs and patterns of 5. And then they had to upload a novel. They had to do the 5 grams from that novel and then graph it as Gephi, as a network. So you can actually trace the patterns of words, you know, in patterns, not pairs, patterns of 5. And so everybody who's taking my class right now is like, thank God we're not doing that. But that's right. All right. So there are tons and tons and tons of applications for this. Again, even if you're not doing sociology, social network analysis, that's where, go to find some tutorials on social network analysis. They will explain all the terms. They will explain all the ways that you calculate this, all of the different numbers that come up. And then you will learn more than you ever really wanted to or needed to, but that's where you're going to get all of them, all of the data. Super. All right. Just a couple more minutes. We'll look at some more stuff here really quickly, and then we'll be done from the day for the day. These were some of the questions that I was bringing to the table when I wanted to explore using data visualization to explore that analysis. The preliminary questions that I was bringing to the table, and I knew I wanted to make a network, told me what I needed to build. So I can't just upload the text of the essay and then have Gephi do all the work for me. I've got to do a lot of the heavy lifting at the beginning, but I knew where I wanted to go, and so I could build that out. Does he favor certain nationalities? Sure does. Certain professions? Okay, so I knew I needed to collect that information because the essay didn't provide it for me, so I had to use an external source. Those questions also give me hints about what kind of data visualizations I can try. And so I wanted to do these as relationships, and so I knew that kind of had to be a network graph. A scatter plot wouldn't really do it for me. The data visualization answers certain kinds of questions. And so people would come to me out of the humanities. They're like, hey, I've got some stuff. I'm reading these essays. Can I do a data viz on this? I'm like, what's your question? And I don't know. I'm like, you go away and think about that, and then I'll take it. Right. The data viz might need certain kind of data formats, and so spreadsheets or those comma separated values CSV files, that's what Gephi really loves. So I know I have to build that. I have to give that to Gephi. And then because it's an iterative process, do I get new questions from this? Can I go back to my data? Does it help me analyze? Does it help me explore? That spreadsheet that we started with the parents of data, super example. That's why I lead with that one, because there's so many interesting patterns that happen in that data that I would not have noticed otherwise. And it drives me back to the data so I can do more analysis. All right. Other tools that you might consider doing later. R is a statistics package. This is free. It is open source. R has turned into a full-fledged programming language actually now. It has transcended and evolved its simple, humble origins. Any statisticians in here? Okay, good. No stats jokes right now. Okay, no stats jokes. I only know two of them anyway. There's a statistician who drowned crossing a river that had an average depth of 2 feet. Every time Elon Musk walks into a room, everybody in the room is on average a billionaire. All right, that's the line. Okay, there you go. R. Do you use R? Yeah. So R is based on well, use the other stats joke I know. Many years ago, a bunch of stats people got together and they wanted to do a programming language to make it easier to do their stats stuff. But because they couldn't really think of a name, they called the language S. And then later, they came along and they wanted to do an open source version of this and kind of give it away. They didn't want to follow S. They were supposedly better than S. They wanted to be something impressive and better than S. And the only thing they could think of is becoming R. Because R comes before S. It is difficult to Google R, but you can find it at r-projects.org and you can download it from there. I do use R for some of the things, but the reason that I use R quite a lot is because my favorite data visualization package is in there. It's called ggplots. It has a goofy name, but it's based in R. That dot plot that I made, that scatter plot, I did that in ggplot. Enormously powerful. They do have a bit of a learning curve. You can do this online. There's a whole bunch of books. I got some books in my bag even right now about R because I'm teaching in class this afternoon. So there's a bit of a learning curve to do R, but it is enormously useful, enormously productive. You can bring CSV files directly into R and then graph them. ggplot has a weird name. The GG is based on this book by Leland Wilkinson called The Grammar of Graphics. And a lot of people are like, hey, I want to read that book. Seems super cool. It's not. Don't. We have a copy in Cameron Library, and I went to get it, and I had to blow about 15 years of dust off of that book because nobody's reading it. It is unreadable. However, a nice fellow from New Zealand by the name of Hadley Wickham read it, and he said, my God, I should make that. And he did. And so that's GG. The graphic, the built-in thing in R is called plot. So you said grammar of graphics plot, so that's why it's called ggplot. One of my favorites. Once you get the hang of ggplot, just like, oh God. You can make a really, really, really cool data visualization in about, if you have everything solved, 90 seconds. It's very, very, very powerful and very predictable. It's really cool. Yeah. There's a whole suite of tools that you can put into R called the tidyverse. And so you can install the tidyverse stuff, and then you get ggplot and a whole bunch of other data cleaning kinds of tools. Super, super, super cool, but not that immediately easy to do. This is kind of what it looks like. You know, I just need to invoke the library of ggplot version 2. I'm going to read in parents.csv. That's a version of what we did today. And then I've got ggplot, and then I'm adding dot points, and I'm adding some stuff. It's like, hey, here's my graph, plus this stuff, plus that stuff, plus the other stuff, plus this, plus that, plus that. And I can just keep adding this stuff on there all I want to. It's just this thing, and then that thing. Please give me that. Give me a title. Give me these axes. Give me this, plus this, plus this, plus that. So, you know, there is a bit of a learning curve to get to R and to get to use R and stuff like that. But this is like all you really need to build some really, really, really impressive data. Okay, that's it. But that's what R looks like if you're interested. Yeah. Animations. Anybody needs to sign up? Super cool. All right. The last one, and I'll put this up in the web browser so you can see it, is called Data-Driven Documents. In fact, you can go there now. If you're in the browser, go to d3js.org and click on examples. Yeah, let's do that. d3js.org, and then click on the examples. This is an interactive data visualization library, so we can build interactive data visualizations on the web that people can run in their web browser. They are amazing. Amazing. Even if you're not doing D3, you can look through all of these sorts of things and get tons and tons of inspiration about data visualizations. Maps, bar charts, graph networks, like just tons and tons and tons of stuff. Because what happens is people use this JavaScript library, D3, they write programming code to build new kinds of data visualizations, and then they give it away. They give it to the D3 community. And they're like, now you guys please use this. And so people can download it, they can change it, they can make new versions, then they can upload that version. It's a big sharing community. And this library is enormous. And it is growing all the time. You'll find in the bibliography here, I put a couple of links. There's one about a basketball team and their point scores, and it's like this panel. It's, oh my God, it's just amazing. And you can scroll all over it and everything moves. They're really, really, really super cool. I don't teach this very often because this is an entire very, very, very crowded semester to get you there. There's a lot of moving parts here. And I think it would only really be possible to do it, to be perfectly honest, as a 2-semester sequence. Because you got to learn HTML markup language, you've got to learn CSS, you have to learn the document object model, you have to learn JavaScript, and then you have to learn the library. It's just, there's a lot of moving parts. But if you find that interesting and you want to go down that path, super cool stuff. And yes, you could get a job right out of the gate. You're like, hey, you get a D3? You're like, I'm a super wizard at D3. I'm like, you are hired. So yeah, this is super fun, cool things to do. But anytime I'm doing a data viz project and I need to look at some stuff, I generally start looking at D3, not because I'm going to use it, but I want to know what people are doing, what these data viz look like, and then I get some ideas. Here's my quick hand-drawn version of where we are and everything. So as we go to the right, those tools give me much more control over what I'm doing. I can change the colors, I can change the outlines, I can do this, I can change the back, I can do all of that sort of stuff. But up means there's more for me to learn. The learning curve for those is a little bit steeper, but this is kind of the path that I think a lot of people are going to be on. We're just some simple exploration stuff, Excel or numbers, super cool, very easy to use, but I don't have a lot of control over what I want those to be. So for example, all of those dots in that spreadsheet were solid dots. I was going to overlay another data set, so I wanted them to be hollow dots. I can't do that in the spreadsheet. I can do that in ggplot. That's very, very easy to do, but I couldn't do it in the spreadsheet. So for me, I just graduate to something a little higher. Some of you might know Tableau. Tableau is very, very popular for doing a lot of data visualizations. It doesn't really do networks very well. It kind of sucks at networks. I think there's a free version, but it's also a licensed version. You will see tons of people, especially in the business community, that just reach for Tableau first. That's their first choice. I don't teach it very often because I like the other tools better, especially the free ones. We did Gephi. Gephi, for my money, is the best network visualization tool. There are others. There's one that comes out of science called cytoscape. Cyto is cells. And so it was developed by scientists to do scientific data, especially with cellular analysis, but you can use it for everything. There's a big project over in the English department, and all of the networks they do is cytoscape. All of them they do is cytoscape. So it's not restricted to scientific data. You can use it for anything you want. There are my favorites, R and ggplot. You don't have to become an expert at R, but learning a little bit of R, just enough to do R so that you can play with ggplot, it's going to just open all the doors for you to do data visualization. Right? There's just so much stuff. And once you get that pattern of start with this, add this axis, add that title, add these colors, whatever. Once you kind of get that pattern, it's just like, okay, I got this. This is pretty simple. The code might look complicated at first, but it's not that bad. And then finally, D3. D3 has the most moving parts, more things that you have to learn. There are some concepts in there that are not intuitively obvious at first, but become so as you work with those. Right? All right. I know we're running on to the end here. Let's see if we can open this here. Maybe it'll open. There you go. This is from Tableau. Except I think it's fine. This is from Tableau. So, take it with a grain of salt, maybe. But here's 12 great books about data visualization that you can read. Again, my favorite guy is Alberto Cairo. For my money, he's super good. Your mileage may vary, but it's just the way that he explains stuff that I really, really, really like. I am not a designer. I didn't grow up with data visualization. I'm an old school hacker programmer kind of guy. And so the way that he explains what he's doing, like, oh, I see why you made that change. There are other people who, I have friends who are graphic designers and like, oh, I just didn't like it. Like, it's fine to me. So I need more explanation. Anyway, he does that. So anyway, you can scroll through these. You can find these books. We have a ton of them in the library. If we only knew any librarians who could help us, that would be super cool. But yeah, so dashboard design is one of them. This one is an interesting book, beautiful visualization, looking at data through the eyes of experts. There's a kind of a map in there. Accidental analyst, show your data who's boss. Here's the one that I brought today, the functional arts by Alberto Cairo. His great explanations. This one is one of the, if you do data visualization as a career, this is one of the must-read books. Anything by Edward Tufte. Visual display of quantitative information is one of the classics. These books are still in print. You can buy them. They are phenomenally expensive. But anyway, there you go. These are some of the really cool ones: cartographies of time, a history of the timeline, doing really, really funky things like that. There are some, I can't remember if it's on this list or not. History of trees as a graphic design principle, history of timelines as graphical design principles. Super interesting books that go back in history. Very, very, very interesting, and like amazing covers, et cetera, et cetera. Infographics. Infographics are traditionally like large posters that have lots of different kind of data on there. One of my friends who's a graphic designer builds those all the time. They're not data viz in the same way. You really have to be a designer to do that. Visual thinking, storytelling with data. This is an enormously popular book. Knowledge is Beautiful by McCandless. I cited a couple of things out of that book. Visualize This, Flowing Data Guide. Super good. Yeah, big book of dashboards. Dashboards are where you can see multiple data visualizations on the same page, kind of like the dashboard of your car, something like that. All right, that's it, believe it or not, for the day. We've got all kinds of time. 2 minutes, minute and a half. But I can hang around and answer some questions, but thanks for your time today. Appreciate you coming. And again, if you're being tried over something, make sure your name is on the email sheet. Thanks to PD, thanks to Nicolette, thanks for hosting in space. Super cool, really glad to be here. And thanks to you guys for coming today. Thanks so much.